In this presentation, we're going to look at integration by parts. This is the first in a series of presentations regarding this subject. So what we have here is an integral which is in the form the integral of u dv. So this is one term here, u, and this is the second term here, dv. And what we have to do is identify v and du from the two terms we were originally given. So we evaluate v by integrating the dv term, and du is evaluated by differentiating u. Okay, so let's look at an example here. So we have an expression here, x times the exponential of x, or e to the x, dx. So we have to identify one of these terms as u. So we're going to let u equal to x. Necessarily du dx is equal to 1. Therefore, du is equal to dx. Okay, we can perform the simple algebraic operations like that. So du is equal to dx. So u we have equal to x, and du is equal to dx. What we're going to do now is determine v, and v is the integral of dv. What is dv here from this? dv necessarily is this part of the expression, this part of the integral. E to the power of x times dx. That is our expression for dv. So what we're going to do is integrate e to the x of dx, and that is simply e to the x. That's just looking for a mathematical formula. Now, just conventionally, it would be the case that you would put in a coefficient of different integration here once you perform a calculation like this. This we'll leave till the end. So right now we'll sort of disregard that. So we have du, we have v, we have dv, and we have u. So we have all the components we need for our solution. I've wrote it out there again. I'll just go through it one more time. And we have v, integral of u dv. So that's u there, and that's v. So this is u v minus v du. And again, this is v here, this is u here, this part here, dv, and this here is u. This is du here, and that corresponds to v. So what we have to do now is integrate this part over here. We still have an integral that we have to work out. It is this one here, this entire integral. It is straightforward enough because e to the x is a very simple integral. So we will end up with x to the power e to the x minus e to the x. Now we put in our coefficient of integration. We'll just leave that in there, our constant term. So that is our answer. Now, again, just be mindful, a lot of these formulas of these calculations, these are just based on well-known differential and integral identities that come from quite often mathematical tables that you would use in your exam. So that is the answer there. I'll just bring it up there just to confirm the answer. The integral of x times e to the x dx equals x times e to the x minus ex plus the constant c. And that ends our presentation.